Hello, my name is Michael Oberle. I'm the Managing Director of ZMT Zurich MedTech, the leading manufacturer of high-precision turnkey solutions for medical implant testing.
The medical implant test systems from ZMT provide a novel turnkey solution to evaluate implant RF and EMC safety during MRI scans according to the latest requirements of the IEC Joint Working Group test specifications. MITS hardware consists of two power amplifiers, a digital synthesizer, an RF waveform generator, a data acquisition system, a system watchdog, and the 1.5 or 3 Tesla birdcage resonator, all controlled by a user-friendly interface. The resonator is a 16-rung high-pass or bandpass birdcage with 2 RF input ports, which excite the 2 orthogonal modes and 4 integrated test ports for automatic adjustment of the incident field. Well-defined and controlled high-precision worst-case field conditions makes the system versatile and allows accurate and repeatable experiments to easily test a range of leads.
Now, since you've learned more about our medical implant test solutions, I will guide you through the process of starting the system, preparing the samples under test, conducting the measurements, and finally visualizing the test results.
MITS solutions employ an elliptical phantom called ELIT, which consists of the phantom tank, shown here already inside a birdcage, and a removable racetrack. A test lead is fixed on the racetrack according to reference markings. The particular phantom design guarantees a tangential E-field with an almost constant and uniform magnitude and phase along the entire lead path. This results in worst-case exposure conditions to evaluate RF heating along the lead. The phantom tank is filled with an appropriate tissue-simulating liquid with permittivity and conductivity accurately characterized at the relevant temperature and frequency. Now, the racetrack with a test lead can be replaced. The MITS user interface gives the user complete control of the required exposure conditions inside the birdcage. First, the signal is specified by setting the pulse repetition rate, pulse shape, and duty cycle. The user can also configure multiple sequences for EMC testing according to the IEC Joint Working Group technical specifications. Next, the user can set the required power level, which is monitored by the amplifiers based on the peak power, or by an optional EZ4 MRI unit based on the B1 field. The user can also configure the polarization as linear or as circular. Now the system can be initialized. During initialization, the system performs a self-calibration procedure. First, a frequency sweep is done to match the amplifiers with the birdcage resonant frequency. Then, a phase sweep determines the phase offset between the integrated test ports to generate the correct polarization. Lastly, an amplitude sweep of the 2 input channels calibrates the attenuation offset of the Q channel for homogeneous field conditions. An optional EZ4 MRI can be used to monitor the B1 and the field polarization. The MITS systems are most effectively used in combination with the DAISY 52 Neo scanner from SPEAC. This robotic system has a repeatability of better than 50 micrometer for positioning the high-precision specialized dosimetric probe. Shown here is a surface scan 2 mm above the lead at 5 mm intervals. The scan resolution can be as fine as 1 mm for characterization of specific features, like the tip of the lead. This system allows effective SAR evaluations in tissue simulating liquids. Relative measurements can be done within minutes, full 3D scans within less than 1 hour. Results can be easily viewed with a DAISY post-processor. Shown here is the interpolated SAR of the surface scan with higher values shown around the lead tip. To aid interpretation of the results, a line extraction of the measured SAR along an axis can be viewed. Shown here is the extraction along the y-axis perpendicular to the lead, at the point where it intersects the tip. Next is shown the extraction along the x-axis, following the length of the lead.
So I hope you enjoyed this little introduction to our medical implant test solutions. If you have more questions, please contact us through our webpage. And I hope that I can welcome you soon as a new collaborating partner of ZMT Zurich MedTech.